Hey everybody, welcome to today's Getting Started with Kubernetes and Rancher online training. Really happy to have you all join us on the line. We're just getting started, so expect more people to join as time goes on. But while we are starting, I just want to let everybody know that this session is being recorded and you will receive the recording and the slides following the presentation. So you will find those in your inbox, hopefully by the end of the day, definitely in the next 24 hours. So with that, let me go ahead and introduce the topics for today and our goals. So we really want to give you a solid technical introduction to Kubernetes using Rancher. We'll go over Kubernetes concepts, and we do have slides to talk about, Kubernetes components and things like that. But we will be doing a lot of demo on Rancher to show you how you can, really extend the possibilities with Rancher managing Kubernetes. As I've said, we have slides, but this will be demo heavy and meant to be interactive. So please ask questions. Questions are always welcome. We try to be educators here, answering what you need to know, what you want to learn, what you came for. And we do our best not to leave until every question is answered. So you can use the chat, the GoToWebinar question feature, which is really cool, to ask us questions. If you want something to be private for whatever reason, just mark it as such. Otherwise we'll answer it, for everyone, so we all can learn from what you've asked. And finally, we really want this to be the beginning of your learning journey and ours too. There's so much here. There's so much to learn. These topics are so vast, and the community is just huge and awesome. We're always creating new things. So we hope that you begin your journey here and continue it. We also do what we call Kubernetes master classes pretty much every Tuesday. We just did one just diving into load balance with Kubernetes last Tuesday, which was just awesome. So there's a ton to see there, and I'll put the link to that later on in the training. And then we also have a survey, and we love feedback. A survey at the end, we love feedback, and it helps us develop new material, new content, teach better, offer what you guys want to learn. So if you have a couple minutes and can do that at the end, it's much appreciated. So as a way of introduction, my name is Matthew Shear. I'm a marketing manager at Rancher. Please feel free to reach me on Twitter or email or on the Rancher Slack. If you have questions or for whatever reason you can't find the recording or the slides, I'm happy to be available and to help out. And our trainer on the line is Jason Van Brackle, Director of Community. Jason, are you there?
I am here.
All right. So yeah, we both are very plugged in and really want to be helpful. So we've included our contact information. Feel free to reach out to us after the training. A couple of housekeeping items before we get going. We hope that you come in with a basic understanding of Docker containers. We will focus more on Kubernetes and container orchestration, talk about pods and things like that. So if you don't know Docker, don't know containers, that's okay. I think you'll still get a ton of the training, but there is a lot of resources on rancher.com, in our blog, in our docs on containers, or of course, around the internet as well. And if you want to have your own instance of Rancher going while Jason is going through his presentation and his demo, you can get one up and running in just a couple clicks. Go to rancher.com, click on the deploy button in the top right. It'll bring you to the quick start guide, and you can get a Rancher up and running in just a couple minutes, totally free to use now and forever. So with this, talking about the resources, I am going to pass the presentation over to our Director of Community, making you the presenter, Jason.
Awesome. And we'll show my screen. Can you see my screen now?
Yes, sir. You're good to go.
All right. So in addition today, if you join our Slack channel, that's at slack.rancher.io. We have a channel called Online Training. I will be there during this training. I won't be able to see it much during the training because I'll be giving the training. But if you have questions after the fact, by all means, reach out to me. Also, in addition to that, we have our forums. It's forums.rancher.com, channels out there for pretty much everything we talk about in the Slack channel. The Slack channel is great for things that are, instant, the community can answer right away. But sometimes there are things that are deeper questions, or that would require screenshots and whatnot. Sometimes the forums are a better place there. I'm out on both. So, if you want to find me, let's open the web browser up. I'll show you a few resources that go beyond just today. So, beyond just today, if you want more training, including more walkthroughs like this in areas not just Rancher itself, but Kubernetes itself, check out our YouTube channel. It's youtube.com/c/Rancher. There's also lots of more links out at rancher.com/training. If there's something that's already happened that you still want to go see, register anyway. Because when you register, you'll get a link to the video, and a lot of those also have GitHub repositories and example code. I know a couple of the master classes I've given, I've also included example code as well. Feel free to follow me on Twitter. I tweet a lot about DevOps and about Kubernetes and about Rancher, but I'm also originally from the Baltimore area, and you'll see me tweet about the Orioles quite a bit because they're terrible this year. And again, if you want to join us today, it's the online training channel on the Rancher Slack. That is slack.rancher.io. And with that, let's get started. So let's talk a little about Kubernetes. It has a ton of momentum and has grown substantially over the last 5-ish years. I like to joke that we're all standing on top of the shoulders of a very small giant because the giant is still younger than my preschooler. So my preschooler, who is entering kindergarten in September, she is older than Kubernetes. So understand that while this is a very large project and supported by big companies like Microsoft, like Red Hat, with other companies like Rancher involved, it's still a very young project. But it has huge momentum. There are other orchestrators in the industry, like Mesosphere and like Nomad, but they don't have nearly the code base or market share, mind share that Kubernetes has. And Kubernetes brings a lot of operational challenges. It is a big, complex beast. Now, it's a very powerful and awesome, big, complex beast, but with it comes a lot of operational challenges that are just one out of the box. So you have how do I centralize my authentication? How do I do multi-tenancy? How do I monitor to make sure all my stuff across all my clusters is working properly and all my applications are functioning properly? How do I handle a multi-cloud provider? Because if you're out in the public cloud, it's not like clouds ever go down, like S3 outages or Azure South Central going down for 72 hours. These things happen. So how do we handle it when things just go awry? So enter Rancher into the picture. Think, complete container management, Kubernetes everywhere. We are completely agnostic as far as where you put your Kubernetes or how you get your Kubernetes. So we have our own Kubernetes distribution. That's RKE for Rancher Kubernetes Engine. It has both a CLI construct, like a kubeadm, but it also is built into the Rancher 2 project. So on top of your IaaS provider and on top of your Kubernetes, you also get Kubernetes management, things like RBAC and upgrades, security, and then application management, application lifecycle management. So application catalog, CI/CD, and monitoring and logging, which are things that you need to run just more than Kubernetes at scale. So today we're going to talk a little Kubernetes 101, and we're going to talk about essentially 5 APIs, pods, deployments, services, config maps, and ingresses, and we'll touch on some things in between that are ancillary. I literally do mean, these are Kubernetes resources, but they're also APIs. If you were to go out onto the web, and that's wrong end of the window you can actually see, not on that screen. Let's pull this over, and if you were to look at actual Kubernetes APIs, it's quite literally APIs. So this is actually from the Kubernetes reference documentation, and you can see each one of the things we're going to talk about is an API today, and we're talking about 5 or 6 of them, but there are lots of them. So that's why I say Kubernetes is hard and it's complex, but it's also very, very powerful. So let's start talking about these, and let's start with pods. So pod. This is our smallest atomic unit of deployment and scale. So we're not thinking about the container, where the containers are inside the pods, but the thing that Kubernetes is most concerned about is the pod itself. And that pod is one or more containers that are co-scheduled. Co-scheduled is just a fancy word for on the same node. So they will never bridge multiple nodes inside of a pod. And that pod has its own unique IP address. There's actually 3 subnets in play in Kubernetes. You have your host subnet, so basically the subnet of all of your nodes where Kubernetes bits are installed. You have a pod subnet for all of the pods that get created by Kubernetes, and you have a services subnet. We'll talk about services later, but these are things that exist in layer 3 and 4 in the OSI model. I don't want to take for granted that you all know what OSI model is, because it does become important in our conversation about Kubernetes. So OSI model, to give you the 90 seconds of OSI model. The OSI model is both a physical and conceptual diagram of how networking traffic works. If you took a comp sci curriculum or a deep class on networking, you got this. But in software systems, this is what I want. One looks like this. So conceptually, information is passed from left to right. Physically, information goes all the way down one stack across the physical wire or the ether or the Wi-Fi and up this way. So layer 7, that's your HTTP and HTTPS, your application level protocols. And then layer 3, 4, we're talking about IP, and we're talking about TCP and UDP generally. There are other protocols, but where we talk about TCP IP, we're talking about layer 4 and 3. So that becomes important to our conversation, because I'll say layer 4 traffic versus layer 7 traffic, and that's what I mean by that. So each pod, its own IP address. Containers inside the pod can speak to each other in localhost, and the container, those containers themselves are just abstractions on top of operating system paradigms so that support application isolation. So pods can be confusing, and I wouldn't worry about it too much. All that has happened is that we've had VMs for so long, and with virtual machines and hardware virtualization, we've just dropped down a level. We're no longer talking about hardware virtualization, but operating system virtualization. And these are these separate, virtualized operating systems are running side by side in user space. The isolation maintained by the engine, that usually being Docker or Containerd or some OCI container engine. And you can think of pods as containers, because sometimes it's a 1-to-1 ratio. I like to think of pods as VMs, because even though they are not virtual machines, they are virtual operating systems. So it's easy for an application developer to think of them as they would have thought of their VMs in earlier years before they got into containerization. And pods of system might look like this, where you have multiple different processes running inside of containers, running inside of the same pod, where they can share a physical file space, a physical network namespace, and other constructs, as if they were on the same machine. They are on the same machine, but as if they were on the same, say, virtual machine, for example. And every spec in Kubernetes that comes out of that API looks something like this, because it's YAML or it's JSON. But you get your API version, your kind for your API, various metadata around this. So the important one we'll look at here are these labels. Because these labels are just key value pairs that Kubernetes cares about. So there are labels and annotations, and labels Kubernetes cares about, and annotations third-party software cares about. Maybe we'll look at an example of that later. And then a spec. So every resource in Kubernetes has its own spec, things it expects. In this case, this spec says, hey, I've got one container in this pod, and that container's name is my app container, and the image is a busybox, which is just a console, and then run this command, which is just bash. It should look familiar, just sh, it should look familiar. So one of the items we didn't talk about, but this gets created, and you'll see this in Kubernetes when it gets created if you're looking at bare Kubernetes, is the replica set. So whereas pods are concerned about which container images or which containers are running inside the pod, the replica set is dealing with count. So the number of identical pods of that type that are being created in the state of that group of pods. And they work a little bit like this. So let's say we have 3 physical nodes. We have our pod. And our pod has, let's see, looks like we have an Nginx web server in there, and Redis. So high-speed key value store, generally used for distributed caching. They are communicating over the web server is communicating 6973 to Redis, and we have 12 of them. So the replica set is defined. It says we need 12. And let's say I'm a klutz. I'm walking to the data center with my coffee. Don't do that. But I am. And I trip and I spill my coffee on a server, and it dies. Well, as long as the remaining infrastructure inside of Kubernetes or inside of your system that Kubernetes is running on has enough resources, memory, CPU, hard drive, all of that, it will go and put those, make sure that you always have that 12. And that's the replica set's only job. So the pod's job is to, make sure containers are hydrated. The replica set's job is count. And so we go to the next thing. So we have, pod, which is abstraction on top of container. We have replica set, which is count of pods. Now we have deployments, another level of abstraction of a replica set. And so deployments create and update replica sets, and it allows us to easily perform rolling upgrades. So what do I mean by that? So let's say we have an application, or we have a pod with a pod spec, similar to what we talked about before. And I have 4 of them running on one node right now because my replica set needs 4. And I modify the spec for this deployment so that I'm no longer using my V1 container, my V2 container. So what happens is the deployment has its own spec that defines how these pods get updated in your infrastructure. So the default is one new one comes up and one old one goes down. Now, this has some, this default behavior has some things we have to think about as application developers, because it means that the APIs that we develop and the applications we develop have to be robust enough to handle rolling updates. Now, you can go everything in V1 goes down and everything V2 comes up, and that's an option as well. Just understand that you're taking on a little bit of downtime there, but that's a doable scenario. So in this case, I have 2 coming down, or 2 coming up and 2 going down, and eventually we'll have all 4 going up. And if there were a problem, I could roll back. And I think by default, I could roll back 10 versions if I wanted to. So this has some things we have to think about as our applications change over time, and backwards compatibility and API compatibility. Look at how complicated the APIs are for Kubernetes, and you'll understand why, because the deployment API has changed a little bit over time. And so, as it's gone from alpha to beta to stable, there's been some maintaining of backwards compatibility there. It's the same thing you have to think about with your application development if you're going to do rolling updates at scale. Like I said, we can roll back to a previous version as well. So services. We've talked about pods and pods having our containers. And then we've talked about replica sets, counts of containers. And we talked about deployments, how our replica sets get upgraded. But we haven't exposed anything yet. They're just out there floating around in Kubernetes, nobody using them yet. That's where services come into play. Now, this is layer 4. Again, we talked about the OSI model. This is your TCP and UDP layer, or TCP IP, UDP IP layer. So services, and that first bullet point is a little bit of a lie, but it's something you can really assume nowadays that you couldn't assume a couple of years ago with Kubernetes. So a service gets an internal DNS address. Remember, this is a separate subnet from what your pods are running on. So it'll have a name like, myservice.svc.cluster.local. That could be changed. Look up your documentation on that. But it's a consistent discoverable endpoint for any group of pods. That could be anywhere within your infrastructure. So your applications no longer need to know what IP something is running on. They just have to know what the service name is. That way, it's discoverability inside of your cluster. And there are 5 different types of services. We have 3 of them here that are the most common. The 2 you don't see, one is called host port, which is useful for the creation of ingress controllers, handling layer 7 traffic into your cluster, and some legacy issues. You probably won't use host port, and once you do use host port, you really know what you're doing there. The second one's called external name, and it quite literally is, I want an internal service name for my thing in Kubernetes that is going to point out to an external DNS address. And that's all it is. I've only seen those a few times in the wild. The use case I see most often with them is that they want an internal name for a database that is managed externally to Kubernetes. Think like an Oracle or SQL Server, something that's not, quote unquote cloud native. And then there's 3 different types. We have node port, cluster IP, and load balancer. Cluster IP just means east-west within the cluster, so from one pod to another or one service to another. Node port is every host in the cluster is listening on the same port on behalf of your application, and the routing happens a little bit magically. And by magically, I mean it's abstraction on top of IP tables. So a bunch of IP tables rules get written when you make node port services so that routing works in Kubernetes. And the third one is the load balancer. And the load balancer is a little bit more magic, but the best example of the load balancer magic is actually from the Kubernetes documentation and its concepts underlying the Cloud Controller Manager. This has the best diagram on this. I probably should have had it open beforehand. Fortunately, Google saves the day. And so this is your Kubernetes cluster, physically speaking. You have etcd, which is our high-speed key value store that was created by CoreOS, now Red Hat, now IBM. You have our Kubernetes master node or control plane node, just depending on who wrote the documentation. And these are all sub-processes. You have your Kube Controller Manager, which is managing all the control loops that are managing Kubernetes constructs. You have the API server, which is quite literally a REST API that everything talks to, including kubectl, so your CLI program, and including Rancher. And then you have your scheduler, and the scheduler decides where in your minions or your worker nodes your stuff is going to go. And then each one of these worker nodes or minions is running two processes. One is kubelet and one is kubeproxy. One is its job is to make sure pods are doing pod things, and the other kubeproxy is a load balancer that helps handle all of this service-based routing and has a few other functions. But the load balancer that we're talking about, this load balancer type of service, relies on this little gray arrow here, and that's the cloud connector. And that cloud connector is a configuration object that connects Kubernetes to the cloud. So when I'm asking for a load balancer type, the implementation of that is up to the cloud provider. So in GKE, it'll create TCP or UDP connections for me. In Azure, it'll create a public IP based load balancer. And that will vary from provider to provider. If this is misconfigured, so it will be an Azure Service Principal or an AWS or IAM role, or a Google JSON IAM service account. If this is misconfigured, this will not work. And when you ask for a load balancer, the status will just be pending forever because there's no connector to the cloud. And then you have to look at the Cloud Controller Manager sub-processes to figure out that something is wrong. So introspection is key. Lots of logging, lots of event collection, lots of monitoring, because you have to understand when problems happen at scale. This might be a good stopping point before we get on to the next, to talking about other types of traffic. Any questions out there, Matt?
There aren't yet. So yeah, reminder everybody, if you do have questions on what Jason is presenting, please ask. But go ahead, Jason. All right.
So, and services, like we talked about, basically work this way. A client will call into usually you have some sort of outside load balancer that would then send traffic into all the nodes, and this service it is listening. So the service essentially, the service has its own IP. In a node port scenario, it'd be listening everywhere, and then the IP tables rules it could create it would route to, and kubeproxy would route traffic to one of the pods throughout your infrastructure. So again, think like layer 4, TCP/IP, UDP/IP, different types of those things. So now we're going from layer 4 to layer 7. So we're talking about layer 7 traffic, or HTTP and HTTPS traffic. So ingress is one of these overloaded terms in Kubernetes. So we have ingress with ingress rules. And these ingress rules define how the traffic from outside the cluster, that being a path or the URL essentially, either host-based routing or path-based routing, gets converted into a service. So the ingress job is to take the service, the route that you asked for, and send it to a back-end layer 4 listening service. And this is how we generally expose Kubernetes services to the outside world. You could just do it with node ports, and there are ways to do that work just fine. But this is the Kubernetes way of handling layer 7, and so we are routing traffic to internal services based on host and path, back to back-end layer 4 services. And these are implemented by what's called ingress controllers. So ingress controllers are specialized pods that are running in Kubernetes that are usually listing on 80 and 443 that are essentially reverse proxy load balancers. So, Nginx, Traffic, HA Proxy all have ingress controller implementations that support the Kubernetes ingress rules. And it might work like this. So we have, myapp.cluster.com or cluster.com/myapp that goes through an ingress controller. In this case, this is the Nginx ingress controller. There's, like I said, there's Traffic. There's a bunch of other ones. There's HA proxy, and then that points to a backend service, the services we talked about earlier. And then from there, it works the same way that all the services work. So we've talked about routing of our packets, and we've talked about exposing our pods. We've talked about pods and compute and how it's managed, but we haven't talked about configuration yet. And there are essentially two ways of storing configuration variables in Kubernetes. One is config map, and one is called a secret. And the only difference between them is encoding. Config maps are plain text encoded, and secrets are base 64 encoded. That doesn't sound very secret, does it? Now, they can be made secret, and the way you make them secret is that, way one is that you encrypt your etcd backend at rest, and all of your providers do that by default now. RKE does that by default, and any etcd, worth its weight in Kubernetes is going to be encrypted at rest. The other way is to do proper encryption using a KVM, and this is a newer method in Kubernetes. I would pass you on to a specific talk that was given back in February, FOSDEM 2019. Base 64 is not encryption, and this is by far one of the best current talks on encryption in Kubernetes and how it should work to make sure that secrets are actually encrypted properly and not just base 64 encoded like it says here. And the idea behind this is that we separate our binary from our configuration. This goes back to 12-factor application methodology for you developers in the room. So developers in the room, if you're developing applications for Kubernetes, you're going to want to read this, take this to heart. This was written by the Heroku crowd a few years ago. But the config map is just storing arbitrary configuration key value pairs, and it's exposed into the pods either as environment variables or as files inside of the container. So you're decoupling your storage of configuration and your versioning of configuration from your application. So not just the pods, but the application itself. So I actually misnamed these. These should all this should say actually, is that name right? Yeah, that name should be different. This should be QA config and prod config. So ignore the names there. I'll fix that. I keep saying I'll fix that, but I will fix that. I'm actually writing down a note now to fix that. But the data, you'll notice the keys are identical, regardless of which the configuration is for, dev, QA, and prod. You'll notice it's the same binary, just different configuration data coming in. It could be different certificate chains, different databases you attach to. All those things that vary from environment to environment, and it could be simple key value pairs like you see here, or it could be full blown, like if you're taking a Java application and moving it over, you might have a Java properties file. So you might have the Java properties file name in here, and the value of that, all the content of the file inside of the value. So to give you an idea of how powerful this is. I put this book up for a reason. One, because it's free. Microsoft has the PDF of this everywhere because Brendan Burns, the author, works for Microsoft on the AKS team. He's a high-level technical leadership there. He also helped start Kubernetes along with Craig McLuckie and Joe Beda and a bunch of other awesome people at Google. So this book is, I compare this book to being the beginning of the Gang of Four conversation for designing distributed systems. So well worth your time. That's why I always bring it up here, and because it's free. So let's demo. Before we demo, Matthew, any questions?
Yeah, there's a couple now. Let's see. Atul asks, what is the difference between a load balancer service and an ingress?
Okay. So a load balancer service. Let's see. Let's go back to my diagrams for a second. So a load balancer service in this case is something that's listening on layer 4, layer 3, 4. So it's listening at an IP address and is routed from the IP address, from that IP address with its own internal DNS name inside the cluster to a set of pods. The difference with the ingress is what flips HTTP, HTTPS traffic. So this is all TCP-based traffic or UDP-based traffic. In the ingress, it is HTTP or HTTPS-based traffic. So it uses the ingress rule to take a path, a URL from the URL to a backend service. And I'll demo this as we go, and go through the Rancher demo time. But good question. What else do we have?
Cool. So Ramana just asked, and this is actually more related to Rancher. He says, how many Kubernetes clusters can Rancher handle?
So that will depend on the size of your Rancher management server itself. And I would have to ask, Bill Maxwell for an update because he does our load testing. But I would say hundreds, if not thousands, are not out of the question. But it does mean you would need a monster cluster to run Rancher on, right, if you were to get to that level of scale.
Okay.
So it might be hundreds of clusters and thousands of nodes, if I remember correctly, the last time that I asked the question. But I'll make sure to ask the question again, so when the next time it comes up, I know what the answer is. Great question, though.
Okay, cool. That's the only ones I see right now, so you can keep going.
All right, then I'm going to take a sip of coffee real quick because I'm clearly not hyper enough. And let's keep going. Let's actually. I'm in Firefox. So I keep a cluster up all the time, and I'm logging in with GitHub. Now, if you created a quick start cluster on your own, it asks you for a cluster URL and admin username and password. I've already done that, and then I've also set up authentication with GitHub to actually protect my cluster. But something to note: when you set up that initial server URL, there are two things you need to know. One, that URL has to be resolvable by every cluster you're going to manage with Rancher, regardless of how it's created. So whether it's created by a Kubernetes provider or with Docker machine and setting up IO nodes, or import it, create it elsewhere and import it, those clusters all need to be able to resolve that URL. So I'm using a public URL here with a proper cert chain. It doesn't necessarily have to have a proper cert chain, but it does need to be resolvable. And two, it cannot change. So whatever you make it, you're going to have to keep it. And this goes back to our metaphor about cattle versus pets. Those unfamiliar with the metaphor, our nodes and our applications and our containers, they're cattle. They're things that we should be able to spin up and die and come back. They're essentially meat. They're the thing they're the things we run our business on. They're the lifeblood of our business, but they're not special to us. They're not like our servers back in our in our bare metal days, our VM days, where they had cute names like Server 01 or Node 01, or perhaps we picked a paradigm like Muppets. So we had servers like Gonzo and Animal. I say that because I work somewhere that used Muppet names for server names. But the idea being that those pets, we cared about them, we upgraded them, we maintained their patches. Versus cattle, which we just we use and then we recreate new ones. So I want you to think about. There are lots of things I won't show you today around automating the creation of clusters with things like Terraform or via Bash scripts. That's all doable. So understand that everything we were looking at can be automated. The UI is a nice, easy way of doing it visually. It's an easy learning mechanism. But understand at scale, all of this can be automated, including your Kubernetes clusters, including even your Rancher clusters. Oh, I haven't logged in a while on this box, so I'm going to do so. And what is this password? I think it's that. No, don't save. Oh, two-factor. Good thing my phone is sitting right here. And we can two-factor in. So yes, if the underlying authentication mechanism that you're using supports two-factor, so will Rancher, which is actually really nice. It's like Azure AD will do that, and some of your open auth systems. And so I just have to find my right auth code. And we're in. And so I have a running Rancher management server, and we're going to go through 3 levels today. We're going to start at global, which is Rancher and all of its Ranchery goodness. We'll go to the cluster level, so each individual cluster, and then down to the project level. Now, project is our own paradigm. Project is an API that we've added to Kubernetes through what's called Custom Resource Definition, or CRD. And Custom Resource Definition is the Kubernetes API for adding APIs to Kubernetes, which just means Kubernetes is extensible and gave us custom resource definitions to add APIs to it. So project is ours, and project is a grouping for Kubernetes namespaces, as well as a way to apply things like resource quotas and auth. So global. We have the ability to provision and manage clusters. Now, I've pre-provisioned some clusters. I've got one running at DigitalOcean right now on the New York 3 region. I have a GKE cluster running, and I have my own other DigitalOcean. This I keep running all the time because I have software running here. If I wanted to add in the cluster, I would pick which provider I want, whether it's a hosted Kubernetes provider, an infrastructure provider, import an existing cluster, or custom, which is generally our bare metal option, which is our most flexible option. And it assumes two things. It assumes that you know how to spin up your own IaaS, and that you know how to install Docker Engine the way that you want it. And the way that one would work is I would hit custom. I would give it a name. I would set up my roles. They can see I already have users here, but I can also add a group to this cluster if I wanted to as users. Let's say my field engineer friends, and I wanted them all to be members of this cluster. I could do that right now. And then set my cluster options. So we support essentially, three of the most recent versions, 1.14 being experimental. What that means is that we just haven't had a chance to do a full Rancher testing run through on 1.14.1 yet. So it should work, it should be fine, but we haven't certified that it actually is. And generally, there's a 6 to 8 week delay between when a Kubernetes version comes out and when the Rancher release comes out that supports that as a non-experimental version. We get the experimental support in as quickly as possible, so that if you want to use the latest and greatest, you can use the latest and greatest. That's pure upstream Kubernetes. We support a number of different network providers. There are ones like Flannel that do not support the network policy API, but are lightning fast. You have others like Canal, that is Calico, which does support network policy API, and Flannel together for network overlay. These are all of your CNI plugins. Too small window to talk about CNI today, but just Google CNI plugin. You'll understand what I'm talking about after a little bit of reading. We have experimental support for Windows Server containers. I actually did a master class on that. So if you go to our rancher.com/training site, you'll see the training out there for our Windows Server container support, and you can watch that video, check out my code, all of that. And then project network isolation. This actually separates network traffic using the network policy API to separate projects and network traffic in projects from one another. You can see here if I were to Flannel, which doesn't support network policy API, I can't use this now. Let's go back to Canal. If you want to see a good breakdown of speed of CNI plugins and decent testing of CNI plugins, actually he's a Rancher user. His name's Infobuilder, both in Rancher Slack and out on Twitter. And he recently did a great rundown of CNI plugins and regularly refreshes that rundown of CNI plugins and their support. So by all means, check that out. And then cloud provider, we mentioned that little gray arrow, that cloud controller manager, that cloud controller configuration. Well, this is how we would go about setting that up. And in this case, I'm not going to do that. And we have some advanced options as well. Check out your documentation. Go read the docs. I say it all the time. Go read the docs. There's lots and lots of things that that go well beyond just our 90 minutes today. That the system does. There's also a CLI here that I won't cover today that you can download. And if you ever have an issue, like I said, we have links to Slack, our forums, and you can even file a GitHub bug right here from within the UI. Now in custom, I say which of the different node types that I want, and then I just run a Docker run command. And this Rancher agent will then go and download the things that you need, and then run Kubernetes inside of Hypercube containers. So Hypercube is a Kubernetes upstream community open source container that has all the Kubernetes processes running in the container, and it just launches the different ones based on the arguments that you send in. And so now this will just sit out here and wait until I have an etcd and a control plane node, or one node that does both, because that's actually the bare minimum for our cluster. But we'll just get rid of this because we don't actually need it today. I will mention, though, everything that we look at again, I'll say it, is backed by a REST API. So all the actions we're looking at, it's all backed by REST. So our CLI works against the same REST API that the UI is working against as well. So all of this can be automated at scale. And I'll just delete this and move on. So apps. We can maintain applications across multiple clusters. So I've got these 3 clusters that are running, in different parts of the internet. This could also apply to a cluster, behind my firewall. And let me just grab something simple and quick like Redis, because I know this will launch really fast. And Helm, for those who are uninitiated, is just helm.sh, and this is a package manager for Kubernetes. So think like Docker Hub for Kubernetes or NPM for Kubernetes applications, where it's fill in the blank templates. But here I'm going to grab Redis. I'm going to fill in a few blanks, just some default blanks. We'd call this Redis multi-cluster. I'm going to target different projects in my different clusters that I want to target. Now I can give it a different upgrades for different types, and how I want to handle the roles. If somebody has access to the project, they have access to this application, or I can do cluster level. I can also override my members, who's allowed to see this. So, by default, they will be able to see this application based on the RBACs they have for that current project, or that current cluster, and I can override this for specific users or specific groups, and I can even override some of the key value pairs of the blanks that I fill in for specific clusters or specific projects. But I'm not going to do that today. I'm just going to set some bare minimum stuff so that we can launch it and just watch it go and be installed to multiple clusters. And so now this will go and install this one application identically into these multiple clusters. Now, on top of this, we can also do multi-cluster ingress support via either Cloudflare or Route 53. My specific server does not have the ability to do that because it's not powerful enough. And so I'm using a single node install versus a highly available install, and it's the highly available install that can support that feature. But now we can see, if we go into our clusters themselves, we can see this Redis application already running in both of these clusters. And those can be maintained and upgraded in tandem. So again, I mentioned users everywhere, so we can tie into various authentication systems. Now, I already have GitHub enabled, but we also support Azure AD, not to be confused with the Active Directory or Exchange, which is also supported. We also support various flavors of LDAP and SAML, including OpenLDAP and Okta and ADFS. So once you actually, connect Rancher to an authentication platform, we can actually authorize users and groups to the platform, whether those be LDAP-based or AD-based or SAML-based, those sorts of things. Settings, I've already mentioned it once, I'll mention it again, this cannot change. Although the drop-down box will say edit and I can change it, if I change this, I will have all manner of pain. Don't do that. Eventually, we will support that. There's a GitHub issue out for it. But yes, don't change the server URL. Then we'll go to security. So we talked about authentication already. Kubernetes has a really, really fine-grained RBAC model. And trying to maintain RBAC across multiple clusters via YAML or via JSON is an absolute nightmare. I did it by hand for a while before I came to Rancher. It is not fun. So we put a nice UI on it. So it could be something as simple as being able to say manage nodes, which gives us the ability to talk to these APIs within Kubernetes and within Rancher with these verbs. And so all the RBAC in Kubernetes is resource verb combinations. That give you different abilities to change things in the API, and they can be even really complicated. So it's not pod security pods, roles, and let's look at it. I think cluster member is pretty complicated. So yes, so imagine trying to maintain something that looks like that in YAML for multiple groups, by hand, maintaining those users and groups by hand in other YAML-y things across your clusters. It's a recipe for insanity. So in addition, we also allow you to modify pod security policies. This is another Kubernetes API. This is a Kubernetes API that controls what your pods are allowed to do running on your hosts. Now, if your Kubernetes cluster does not have the support built in for pod security policies, this is just a pretty screen that does nothing. You actually have to have the pod security policy emission controller running. Some of the cloud providers have it, some of them don't. We will do, if you turn it on by default in RKE, it will be on, and this will work. One thing of note: if you launch a Kubernetes cluster that it does not have what's called the pod security policy emission controller running, and you go and you turn it on, but you don't have any policies created, you won't be able to create pods. It locks everything down because there are no policies. That's why, by default, we create an unrestricted and a restricted policy. These are really just to protect you, just in case you turn on the emission controller without a policy. So you can't. We created two policies. But this allows you to do everything from control what type of volumes you can mount, to whether you can see the host network, to whether you can, have a privileged container, or you can escalate to it being a privileged container. So if you want to talk to like 80 and 443, for example, you need some privileges to do that. Linux capabilities, volume policies, even AppArmor and seccomp profiles can be applied to pod security policies. So before I drop down to the cluster level, any questions?
There's one kind of general question from Ramana, who asks, is there any free tier of Rancher, freeware to download and test for training purposes?
Everything you're looking at right now is 100% open source. So Rancher itself is an open source project. If I go out to github.com/rancher/rancher, all the code for it is here. If you go to our install documentation, if you want to start playing with it yourself, you go to the quick start guide that was mentioned earlier, or you could go to read the docs and installation. And we're actually working off of a single node install today. So it's this demo environment. But yeah, so all of this is, I believe, it's Apache license. Let's take a look. The license file is right here, and I bet this is Apache 2 licensed. So, so this is, there's no concept of, where Red Hat, for example, has Fedora and RHEL. Like, it's just one Rancher. We don't hide tools. We're open source types. We have a very giving culture. So while we have 20 to 30,000 different teams using this open source, we have another several hundred of them that are paying essentially for support contracts. So think legal indemnity and 24/7 support, which is how we keep the lights on. But good question.
Cool. That was the only one.
Okay. Then I will drop down from global down to cluster level. Let's grab my GKE cluster here. So depending on how the cluster was created will depend on the control we have here. So this GKE cluster, we have no control over the control plane or etcd. Google manages that for us. We also can't update nodes from within here. So if I were to go over to nodes, I can't modify the nodes. But if I were to modify the underlying node pools over in GKE, they would show up here because we're just talking to the Kubernetes API. Now, if we use an IaaS provider like DigitalOcean, where Rancher actually created the IaaS on behalf of this cluster, and I created this one this morning, we can do just that, and we can actually create more nodes. So I'm actually going to create a second node. And what's going to happen now is it's using my API credentials to talk to DigitalOcean, spinning up DigitalOcean droplets of this specific type that I gave it. So this is my name for this type this is my name for this. It just tells me it is a New York 3 droplet, which is one of the regions in DigitalOcean, with 4 gigs of RAM and an 8 gigabyte hard drive with 2 virtual CPUs running Ubuntu 16. So I can have these are node pools. I have different node pools for different types of nodes that have different functions. Now I'm using one node pool here for all of my things, but let's say if I had some nodes that I wanted just general purpose, and I had some nodes that I wanted with GPUs for doing machine learning, and I had some node pools with some specialized piece of hardware that I needed for a certain job function, I have the ability to do that. And that's what's happening. So once that node is created, the Rancher will SSH in, install Docker using our scripts, which you can change in our settings if you want your own Docker install. And then once that's up, it will install Kubernetes via those Hypercube containers I talked about earlier. If I were to scale up and down the control plane or etcd, the brain would shut down in Kubernetes for a while it was going from the single node to cluster, or the cluster is being changed, but all my guest apps would still run, and then eventually everything would come back up. And for some reason, if later I wanted to go through and actually upgrade the version of this cluster, so I'm running, what's this, 113. If I wanted to upgrade this to 114, it would just be a matter of, so I can add more node pools here via my node templates. But I can just upgrade my Kubernetes version as well. We can't downgrade, but we can upgrade. And let me save this, and this will actually go through and upgrade this cluster. And that cluster will slowly update from 113 to 114, and we can see how it's going as it's going. Now, let's actually do this from the GKE clusters. This one is, since I've ripped this thing's brain and it's upgrading Kubernetes, let's go to my other cluster so I can show off monitoring. So from this cluster screen, we can see which resources have been reserved for Kubernetes. We also launch kubectl or kubectl or kubectl, depending on how you pronounce it. The official, I think, is kubectl. I think it's the official, but I don't care. And this will respect the RBAC of the current user. So if I want to see everything running in this cluster right now, I can do just that. And this will also do command line completion. So if I do a kubectl and I spell kubectl right, and I do a get, I can get all my different types that I want to look at, like jobs. I don't think I have any jobs here. And if you're like me and you like to use tools like kubps1 or kubectx and kubns, but you need your own kubeconfig file for that, you can grab just that. And you can see here that I had that available to me that I can then use to implement this in my command line. If you need kubectl, it's not the download link. It's the link to the documentation out in Kubernetes with the download links and how to get it for your operating system. Now, we have a cluster. We can see some things are going on, but what if we want to see more? We can enable monitoring, and we're going to do just that. So when we enable monitoring, and I'm just going to take the same defaults, cluster level monitoring gets enabled, and a bunch of things are being added to the system project. So if I go out to the system project, I see all the things that Google already put out there for me. I see the stuff that we put out there to run Rancher management on this cluster. But then we have this new namespace coming out called Cattle Prometheus, which is installing a piece of software called Prometheus and a piece of software called Grafana. Prometheus is a metrics collection system, and Grafana is a visualization system that makes pretty graphs for all the stuff. Doing this by hand, you can do this by hand. There's no reason that you have to use ours. We just took the community. I hate the word best practices. We'll say enterprise level scale practices, and integrated that into Rancher with the push of a button. So once that is up and running, that's going to start, collecting metrics, and our cluster screen actually gets more detailed because, there's more information coming from Prometheus. Well, the monitoring API hasn't quite started collecting everything yet because these will actually have more information on them, but we already have our Grafana charts and graphs. So the monitoring API has come up. Monitoring API is actually scraping the same Prometheus that Grafana is scraping to get all kinds of information about what's going on in our various nodes, about network traffic and disk I/O, about Kubernetes component latency, and even logging metrics. We turn on logging. I don't have logging on right now. And then we can switch. Now that Prometheus is running, we're actually getting more information, more detailed information. So we have, this is all this is reservations, and this is actually in use. So the in-use data is actually being pulled by Prometheus via the node exporter and via Kubernetes metric system and things of that nature back to the UI. And there's just, there's some data we're not getting around the pods. And I have to look into why we're not getting that. GKE could be blocking it, or something that our configuration hasn't started up yet. But then for every one of these, we also get the backing Grafana visualizations that are great for Kubernetes. So not just cluster level visualizations, but also pod level visualizations. So we have our cluster level visualizations. We're not going to see a whole lot here because it just started collecting, 30 seconds ago. But over the next, while, we'll see that. So if I go over to my other cluster that has been running for a while, I think I have monitoring turned on here. I do. I should see a lot more information about this cluster over time. So if I go to my cluster Grafana here, I should be able to see a lot more information of what's been going on in this system over time. Now, you can see here, this is only a 4-node system. I've got 0 replicas of this one thing called Welcomer that is not running right now. But I can see lots more information of what's going on inside of Kubernetes around pod memory usage, CPU usage, even down to network I/O, which can be really, really useful. See here, Canal is using a lot of network, not network I/O, but it should be. It's part of the CNI plugin. It's its job. So storage, I'm not going to cover storage today because storage is a really big topic. But if you want to deep dive into storage, we did one back in September. So if you go to YouTube, let's Where is that? Yeah, I think I already had it up. Oh, nope, I closed that screen earlier. You go to youtube.com/c/rancher, and you go down to all of our uploads. If you look for the September 2018 online meetup, so I'm going to go ahead and open up uploads, and if we go to September 2018 online meetup, you'll have a full couple of hours on Kubernetes storage APIs, as well as a Longhorn, which is an open source project that we are running to do distributed block storage in Kubernetes. So check that out. As I mentioned before, projects and namespaces. Projects are just grouping for namespaces. So we already have our namespaces here for cattle and for kube system and ingress controllers and our Redis install from earlier. Think of namespace like a virtual cluster within a cluster, except that virtual cluster of the cluster has resource controls around it and RBAC around it to help restrict what users can do. As far as add a project here, I can create a project, attach a pod security policy for it, put my different members of RBAC, and stick my resource quotas and default resource limits against it. Now, I would recommend using default resource limits that are stupid low, like 0 and 0. That way, it forces your software developers to do the kind of metrics collection and resource utilization of their applications, something that looks like this, for their applications, so that when they define their YAML for their applications and their Helm templates for their applications, they know what resources they need, so you can give them proper quotas for the things they need. That way they're not taking down your entire cluster. And don't forget to also put resource quotas around things like pods and services, because remember, those are IPs, and those subnets that they're on have limited amounts of IPs. So you don't want, a malicious developer who's having a bad day decide he or she is going to take up all of the IPs in the subnet just to see if they can, because then nobody else can create services or pods. That would be a bad thing. And that's what projects and namespaces are for. And we've already talked a little bit about users and tools. We have a bunch of different tools. We've already talked about monitoring, logging. So we will turn on FluentD and 4 logs to these various different logging systems. So whereas Prometheus and Grafana are dealing with machine data, logging is dealing with the actual logs. So think structured logging. That might look something like, like one of these down here. And I'll warn you here that the cluster level logging is a fire hose. It sends everything for all applications, from standard out and standard error to wherever you forward it. That means that if you're paying for Splunk, which you're paying for by index gigabyte per month, and you don't want to pay an arm and a leg and rename your dog and your firstborn child Splunk, don't turn this on at the cluster level unless you have the back end and the money to support the license of that size. There's also project level logging that looks identical and works the same way, but is only grabbing information at the project level. So before we drop down to project level, any more questions from the crowd?
Yeah, there are. This one's from Dan. I think you might have answered it already, but just in case, he says, can you manage clusters across multiple cloud platforms or on-premise?
Absolutely. So these are all on different clouds, and if I wanted to do an on-prem bare metal platform, I would just go down this custom route here. It's a good question.
Cool. Okay. Next one is from Atul, who asks, does adding more nodes to etcd and control planes automatically make these HA?
Absolutely. So if I were to go in here, actually let's just do it, because I can use my GKE for demoing while it's doing its thing. So if I go into this specific cluster, and because this one I have the ability to create nodes in because it's a DigitalOcean backed cluster, and I can just create nodes on the fly. Let's go ahead and edit this, and let's actually change our count of control plane nodes. Let's grab 2 of these, and etcd can't even, so it has to be odd. And we'll grab 3. So if I try to do 2, it will warn me. I can't get a quorum with 2. Waste of hardware. So we have to do 3. So and if I have the space in DigitalOcean, because we share this with the entire team, it should be able to create those as a cluster. And so it will upgrade us, tell us how it's going as it's going. So I forgot to mention earlier, so other tools, alerting. So Prometheus also has something called Prometheus Alert Manager, which will send alerts. So we have the ability to alert on node health and application health and a whole bunch of other stuff, including etcd has no leader. So if our etcd cluster has no leader, then etcd isn't working at all, and it's a bad thing. And so we can actually attach to metrics that Prometheus is grabbing. There's no metric graph data because, I wonder why there's no graph data for that metric. I would expect graph data for that metric because I have monitoring turned on. I did not turn on monitoring here. No, the monitoring turned on. It's because I just don't have any data on that metric. Oh, I can't see etcd because it's GKE. It would have to be a cluster where I actually manage etcd. So let's grab something we will have a metric on, like, let's see, high CPU load. That's a good metric. And we can see here, high CPU load, if we have greater than 100 for 3 minutes, so maybe it's like 80% is more your style. We can actually put it 80, and we see it's sum of the node load 1 by instance. And this is just PromQL, so Prometheus query language. Hey, Matthew, I've got a little bit of an echo.
Oh, sorry, I think I was unmuted. My apologies.
No problem. So once you have the alerts in here, those alerts can send out notifications. This is another part of Prometheus Alert Manager. So we can send out notifications to Slack, to email, to PagerDuty, to WeChat, and to anything that understands webhook. And if your alerting system doesn't understand webhook, replace your alerting system because then it's really, really old and should be replaced anyway. Because everything understands webhook nowadays. It's essential. Catalogs. So again, this is Helm oriented. We can manage Helm catalogs at the global level, at the cluster level, at the project level. So you can have a Helm catalog available to everyone, to just specific clusters or just specific projects. And so Helm has basic ways of creating chart repositories, the details of which are available in the link. I won't go too deep into that, but we'll constantly update the available applications both in your projects and in the multi-cluster apps, based on where you have your repos. So global catalogs, for example, allow us to have multi-cluster apps available everywhere. So dropping down to our project level now. The default namespace gets a default project. We already have our Redis workload running here, but if I want to create another workload, I go to deploy. Let's just grab Nginx, which is a high-speed web server. So if I wanted my own repo that was not, or my own image repository that was not the public Docker hub, I could say like KIO, /GVB, /my stuff, my stuff, my tag latest. But I don't actually have one called my stuff. So let's just grab Nginx. Actually, before we do that, let's go create a config map and a secret, or just a config map will work just fine. Redis has one already, but we'll create one called my config map, and we'll give it my key, dot key, and my value. I can actually do new lines and things like that in here as well. Like I said, this could be a whole file, like a Java properties file, where this be like my properties file name, and this be the value in there, or I can even import it from a file. So let's save that config map. If I want to do private registry, I would just add my registry here. So it can be my KIO or my private Docker hub or my internal custom one, as long as it speaks, Docker registry. We can also create certificates, and certificates are just a subset of secrets. Again, base 64 encoded value, where I have my secret, my value and my key, or my certificate and my key, that I can then attach to my layer 7 application-based ingress rules. But we'll go back to our simple workload, and we'll grab our Nginx here. We have our different workload types, so we talk about deployments, but you also have the daemon set, which is one on every node, a stateful set, which has stateful set mechanics, which check out your Kubernetes documentation on that, useful for doing things like databases in Kubernetes, which is a complicated beast. Like I said, I talk about storage elsewhere for a reason. And then cron jobs and jobs. Cron jobs is exactly what it sounds like. Run a container job every cron schedule, or a job which is kind of one run to success, and then be done. But we'll do a deployment here, and we're going to create our Kubernetes service. So we talked about our service, our layer 4 right here. node port. I can do a layer 4 load balancer because I'm on Google, so I can have a public IP. So let's create that public IP. And we'll actually watch that being created. I can create my own environment variables if I'd like. I don't really need to here, but I can also inject them from a secret or a config map. So I'll grab my config map and the one that we created. This is node affinity and anti-affinity, so we can actually apply labels or key value pairs to our nodes and labels and key value pairs to our application, or actually selectors, which are queries on our key value pairs, that determine where my pods end up. Now, in this case, that's beyond what we're going to talk about today, but no, that's called node affinity and anti-affinity in the docs. And then we have liveness check and readiness check, and the difference is this. Liveness check is like scheduler based. It tells the scheduler, hey, I'm alive, I'm around, please don't reschedule me unless you absolutely have to, like you have to preempt me for some reason. And readiness check says, not only am I alive, but I'm ready to receive traffic, so kubeproxy, feel free to send me traffic. Now, generally in microservices where they're really, really tiny, this is one and the same, and you just do a readiness check. But let's say you're taking a Java monolith, and you have a JRE that has a big memory need. Well, that JRE is not going to start up instantly, and that class loader is not going to install all your classes instantly. So it might be a little bit of time between I'm alive and my application is running and ready to receive traffic. And that's the differentiation between the two come from. Volumes. So let's create some different types of volumes. We'll create an ephemeral volume, which just means it will die when the pod is gone, when the pods are gone. And this will be our in-memory volume. We're going to have 30 megabytes. Those are megabytes for anybody who is over 30. And we'll mount those inside of our container at a directory called temporary. Let's see, I'm on GKE, right? This is GKE cluster? Yes, it's GKE cluster. So I have the ability to create persistent volumes, persistent volume claims via storage class. So I'm going to use my default storage class, which is just called standard, that Google created for me. We'll give it 3 gigs or gigabytes, and we'll call this my Google volume. And then we'll mount it in here as Google. And then I'm going to do something evil, because this is why pod security policies are important. And I use this as an example for why pod security policies are important. So I'm going to grab the path on the host called Etsy, which has all my configuration in there, and grab Etsy mount. Now, you may have reasons for that you want to do that, but you don't want to just give your developers the ability to do that without them actually having to be able to do that. And then we'll grab one, like I said, config maps and secrets can also be files in your file system. And then this is our deployment API. We talked about how that rolling update works. That's all in here. And we're going to launch that. So this individual deployment is coming up. We can see the individual pods launching and see their current status, whether they're available or not. I can see lots and lots of things going on here. I'm just going to expand all. And I can see here that it was the containers weren't ready yet and they're initialized, but we go from ready to scheduled to everything's up and running. And now we're at everything's up and running. Now, as this thing is running, it will get data, because there are collection mechanisms in Kubernetes allow Prometheus to pull data. So we have a Grafana chart to also show that data off. So let's give this thing some traffic, and we'll also need a couple of minutes to actually run through that data. But if I go back to my workloads, because I created I don't have my load balancer yet, we'd have to wait for, was it cloud? Cloud.console or is it console.cloud? Always do this. Let's find out. Cloud.console.google.com. Nope. There we go. Console.cloud.google.com. I just did backwards, didn't I? Oh, I didn't use HTTPS as well. So I did 2 things wrong. But we should be having a load balancer created because our cluster is already here. If I go in, I keep a network services pinned, so I can turn on load balancing, and I should be able to see that TCP-based load balancer is being created or already created. So I have 3 nodes that can collect TCP data, and that's my target pool, which is my back end. And so if I now go into here, I still don't have it yet. So it takes a moment for that to work, but we can see here we've already defined the load balancer. It's just not up, it's still pending. And now it's active. So I go back to my workload, I should now have a public IP address, and I do. It's actually a public IP that you all could hit. So it's up there and it's running. Please don't DDoS me. Yeah, so it's up and running. So that's our layer 4 TCP-based load balancer. So it's TCP IP-based, listening on 80, exposed via shown off as a layer 4 load balancer here, and also shown as a Kubernetes service. So we can see here our service here already listening on 80 as well. But what if we want to create layer 7 ingress? We can do that as well. So I don't have a domain to use, but fortunately we provide a development scale host name provided by ZipIO. And for those familiar with Let's Encrypt, think of ZipIO as poor man's Class A DNS. Like Let's Encrypt is public certificates for everyone. So I'll do this ing for Nginx. We'll use that ZipIO. And basically how this works is you give it an IP address with the ZipIO on the end, and it gives you that IP address back. And so I can either choose the workload, and that will create services for me, or if I already have a service, like my public load balancer, I can use that. And so I will create that. If I had certificates here, it would work. And here it will warn you, hey, it may take a few minutes for the Kubernetes engine to allocate external IP resources. Really, it's going to take a minute for Kubernetes to talk through the Cloud Controller Manager to Google Cloud, and for Google Cloud to go and create that external IP, the external DNS name, and for all of that to wire together. And that will take a couple of minutes. So we'll get that running, and you can see here's a layer 4 balancer, here's a layer 7 ingress. If you want to see what the definition of that looks like in a Kubernetes way, we can actually go in and view either the API for the REST implementation in Rancher, or the actual YAML for Kubernetes. This is runtime YAML. We can see API version, we can see it's an ingress. We have our annotations. Some of our annotations, these are key value pairs that third-party items care about that are not Kubernetes. So in this case, Rancher, things Rancher cares about. Labels, this has a key value pair for a label itself that we're tracking. So we track labels and annotations on things. And we can see here it has a spec, and this will change when ZipIO responds to IP address.zipio. And we can see here anything that comes in on that host with an empty path will go to my load balancer on port 80. So this is our conversion from layer 7, HTTP, HTTPS, to layer 4, TCP IP. And we'll let that keep doing its thing. And this will actually change a little bit now that ZipIO responded and we have a proper IP address. So if you add the YAML and go down to the bottom, we can see here now the host name has changed, the load balancer, and there is a public IP for the ingress, but I bet it's not active yet. Let's find out. Nope. So you Google, this takes a few minutes for Google to get that layer 7 load balancer up. So we go back to our network sources and we refresh the page. We will see HTTP-based backends coming up, but we'll see we don't have any endpoints up yet. So while the backend is up, it's not all wired together and it takes a minute. We'll hit a reload on here a few times for some more traffic. That is still doing its thing. Let's find out if it's up yet. No, it's not up yet. Now I wonder, let's see if we have any pod level metrics about this. So I can see now, you see I have a port 80 HTTP and a port 80 TCP. And let's actually look at the pod and see the pod level metrics of what's going on here. And we actually have some CPU and memory utilization. And you can see here me hitting my reload button. And I can actually go to the underlying Grafana dashboard for this as well. And so this will be available for every pod in my cluster as soon as it's created. So I can see here the network usage, the CPU usage, and the memory usage of this specific pod, which is kind of awesome. We can also go inside the pod and see what's going on. So I can see the logs and view the logs inside the pod. None of y'all are hitting that IP address because I have a lot more logs here. And we can even jump inside and we can execute a shell. This would be the same thing as doing a kubectl exec with a bin bash, for example. And I can see inside of here, and I can even df, and you can see here my temporary, my Etsy mount, my Google, and I can even go in and look at that Etsy mount and see all kinds of Etsy things that I shouldn't be able to see. Use your pod security policies. So we can do applications that way. We can also do applications through our catalogs. You can already see our multi-cluster app here running because it's the same. It's also using Helm. But if we want one for just this cluster, I could launch an application here for just this cluster. And let's grab, let's say, Chart Museum. And Chart Museum is actually a is actually for hosting your own Helm chart repos. We hit Chart Museum, fill in a few blanks, shall we? Oh, so earlier there was nice fill in the blanks here. Now that was for ones that are curated by Rancher. Ones that are not curated by Rancher are just plain Helm. But we can look in the detailed description, and we can even see the things that you need for using with various backing stores. I'm going to grab the Rancher one because the Rancher one will actually just have some sane defaults for me to work on because I don't know all the keys off the top of my head because I don't demo Chart Museum all that often. But it will do S3 back storage for everything. I'm going to use Google. So I don't want to use Google storage. I want to use a local storage, and I want to use a storage class. So I'm going to actually create storage. I don't need to use the existing claim. I already have one that I'm going to create. Default image is fine. Absolute URL. Don't need to worry about all that. Yeah, we'll show advanced. No, we'll do advanced. We'll do simple. Basic password, optional. Yeah, we'll just do the bare minimum, and we'll let this run. And so this is now installing all the things you need to run Chart Museum, and we can actually watch the pieces come up as they're coming up. So we have all these default environment variables to get Chart Museum up and running. We have various workloads are running, so they're in the pods. We have ingress rules for Chart Museum. We have various services that things can communicate in Chart Museum. We have volumes for storage that is creating that in Google for me so I can store things. And it has its own secrets as well that we can't see because they are not ours and they are base64 encoded. So I can go into Kubernetes and pull out the encoding unless I encrypt them properly. And let's see if we have this now listed. MyManagementCluster.com. So we eventually will have a Chart Museum up and running, and we could actually host our own Helm charts. Oh, there it says Mentif.io. Yeah, Google is still working on that whole Layer 7 thing. So this one up, the Nginx one that I launched like 5 minutes ago is now up and running. So that's good to know. And then again, that one will take its own several minutes to come up, but will eventually come up. But just like that, I could host my own Helm charts now. So we already talked about our resources, and we've talked about namespaces and projects and members and membership. Here we have the same things in here. We have alerting and catalogs for having your own, and then we have this pipeline feature. And this pipeline feature is CI/CD for your system. So you can actually talk to existing repos. Let's see. Let's go ahead and authenticate. I already have this upping. We can authorize that. Fail OAuth config. I probably have this is old OAuth, so I can't demo this today. But the idea is that you can hook into your CI/CD systems and connect your actual code. To Rancher. So Rancher will actually, create a copy of Jenkins in a Jenkins file for you, pull your code down, compile your code. Use your Docker file to push to your Docker repo, and then use your Helm chart to deploy, or just your YAML to deploy into your Kubernetes cluster. So like other CI/CD systems. It's a V1 of this feature. This feature will continue to iterate and get more advanced. So it's not as full featured as, say, a full-blown, Jenkins pipeline or a full-blown, the Azure DevOps or one of those tools, but it's a great place to start if you're starting from zero and you're starting with Kubernetes. If we also, like I said, we have a CLI. If you want to work with a CLI, you need an API key. And you go up here and you create API keys as well. Just know that the API keys you create have the same RBAC that you have. And they actually say here, any keys you create will be able to do all the things you have access to. So understand that when you create one, you create a key with your RBAC, just like everything else. And then you can authenticate via curl or via our Rancher CLI. So I have covered everything from global to cluster to project. Does anybody have any questions?
Awesome, Jason. Thank you so much for going through that. There's a couple questions. This one is from Atul, who asks, what's the difference between RKE and Rancher 2.x?
So RKE is the Rancher Kubernetes engine. It's actually built into Rancher 2. So it's actually a full separate project. Excuse me. My cat is actually pulling on my audio cord right now. There we go. I've got my cat free. So
Okay.
RKE is a separate open source project. So I go to github.com/rancher/RKE. This is the Rancher Kubernetes engine. This is the CLI version, but this is also built into Rancher 2. So RKE is a subset of tools that goes into Rancher, and if you're doing a highly available install of Rancher, you'll actually use RKE to stand up a Kubernetes cluster to then install the Rancher system on. Good question.
Cool. Okay. This was asked a tool earlier. He asked, when you add a new worker node, such as DigitalOcean, which size and which distribution will be added?
So that will depend on my node template. So I actually go to my node templates. I have these predefined that I use over and over again for different demos. But let's grab one of my DigitalOcean ones. Let's grab this. Let's grab the one I just used today. These 480s. So when you define, so I'm going to use my cloud, so I can store cloud credentials for my various clouds, and they configure my droplets. So it's my DigitalOcean droplet. So these options will be based on the Docker machine node driver that we're using. So we're using open source node drivers to do this. Docker machine is just another open source tool that we don't own. It's something else that we're just ingesting to talk to IaaS providers. So the determination will be based on the node template and based on what the Docker machine driver can do. So in this case, I can change from all these different regions, all these various droplet sizes that are supported by DigitalOcean, as well as, where'd that go? As well as the various images that are supported by, in this case, DigitalOcean, but essentially by the IaaS provider. Good question.
Okay, cool. Here's the next one. The language is a little challenging. You might need to read it, but it is, will Rancher support being installed into Docker containers, and can we test it?
So Rancher can be standalone because Rancher itself is a Docker container. So if you were to go out to docs.rancher.com, navigate to read the docs, then go to installation. Make sure you read your node requirements. That's important, especially around ports and things of that nature. But then go down to single node install, and this will walk you through doing a single node install, which is essentially launching Rancher. So we'll do the option A, self-sign. It literally is this. That is the simplest installation of Rancher that you could possibly do, having Docker already installed.
Cool. Okay, sweet. Let's see, here's the next one. Is it advisable to use Rancher OS instead of Ubuntu or another OS?
This is one. It depends on what you need. So Ubuntu is a larger server-based Linux distribution. It has a lot more tools, a lot more features in it. Rancher OS is a minimalist Linux distribution. So Rancher OS is another open source project that was started by Rancher Labs, and Rancher OS is literally enough Linux to run Docker, and then everything else is run in a Docker container, including things like system tools. So there's actually no persistent console in Rancher OS. You actually have to, if you were to use a persistent console, you have to actually grab the Ubuntu console versus a BusyBox console, which is the default. So it depends. So Rancher OS, for example, is really big in the finance space because it has a really small attack surface because it's a really small Linux distribution. But it's not required to run Rancher. It's just another open source project that we've developed that has a specific purpose. But good question.
Okay, great. That's the last question that I see asked. Is there anything else you want to leave us with, Jason?
So yeah, so if you have any follow-up questions, please come join us on our Slack channel at slack.rancher.io. Out there, as Matthew mentioned earlier, I'm at JVB, so it's Juliet Victor Bravo. If you join our Slack channel, you'll get a personal message from me. Now, technically, that is automated because I was sending out 30 or more of these a day, and it just got time-consuming. So I wrote code to send everybody a welcome message, but it goes in my Slack history. And if you respond to it, you're responding to me. It's not some fancy bot. I'll actually answer your questions, help you out. yeah, we have a hashtag, Kubernetes channel. We have a hashtag general. We have a hashtag vSphere for specialized installations of Kubernetes and of Rancher, and we're out there just to help. So, by all means, come see me out there. Follow me on Twitter. Feel free to hit me up on LinkedIn. If you hit me up on LinkedIn, just let me know you heard me here, so I know you're not recruiter spam.
Awesome. Okay, great. And I just want to show a last couple slides for the
Sure
Kubernetes
thing. Let me.
class.
Here you go.
Okay, myself presenter. And okie dokie. All right, so yes, as Jason was saying, slack.rancher.io. And as I mentioned at the beginning, we also do some more advanced training sessions on various topics on Tuesdays. So rancher.com/kubernetes-master-class. For all those, they're just like this one. They are free. You can get the recording and the slides. Next week will be really cool because Wizards of the Coast is presenting on their production deployment. So if you like Magic the Gathering, as I definitely do, definitely attend that one. It'd be really cool. And our Twitter hashtag for these is here, #PoundRancherK8. So if you want to give us a shout out, we'd love that. And as I mentioned at the beginning as well, there is a survey at the end. Take a couple of minutes, fill that out. We'll use that to develop new content for you all. And this session will be sent to you shortly. So look forward in your email. All right, thanks, Jason. Well done, and thanks everybody for being here.
Thank you all.
Okay, bye-bye.